to finish up section 4.2. So we've got one problem to look at. It's find the area of the region bounded by the graph, f of x equals x cubed, the x-axis and the vertical lines x equals 0 and x equals 1 as shown in the figure. So this is what we're looking at. And our goal is to find the area of the pink region. Okay, we want to find the area underneath that curve. And so in order to do that, we're going to follow some of the steps we did yesterday. We're not necessarily going to find the upper and lower sums. We're just going to find one answer. So it's not a matter of we're finding the uppers and we're finding the lowers. We're just going to find one of those two. And so first of all, we need to find the width of the rectangles that we're dealing with. Ooh, that was a good one. Let's try that one again. We need to find the width of the rectangles that we're dealing with. So to find the width, remember that was delta x. And how am I going to find that here?
Something over n.
Yep, something over n.
2 minus 0.
Not 2.
Is this 1?
1 minus 0. Now, what you're going to use is you're going to use your endpoints here. Your vertical line is 1, and your other vertical line is 0. So that's what you're subtracting. Okay, those are the two things that you subtract. And so you get 1 over n. So that's the width of those rectangles. Now, if you remember, yesterday we summed those. And we did I equals 1 to n. And then I summed 1 over n. That was the width of the rectangle. And now I need to find the height. And so the best way to do that is to find what height best would represent the area. And if I look at this, would it be best to represent the area by going above the graph? Or would it be best to represent the area by going underneath the graph? I would probably go above, because if you go underneath, look at all this area that you're missing. Okay, I mean that's going to be pretty hard to get because look at how close to the x-axis it is. So I would go with the values above, and so the values above, at 1, I'm actually going to be at what f of 1 is. And so in this case, if you remember what we did, is, oops, I wrote the wrong thing, sorry. F of I over n. Okay, because this is the one that we were not looking at the previous rectangle height. Okay, let's look at that again. If I'm at 1, right, and I want to find the rectangle above, my height of my rectangle is going to go all the way up to this value. And then it's going to go to the left.
So it really has nothing to do with that little rectangle right there.
Not really, you're drawing. My suggestion is always to go to the last rectangle you can draw, because that way it's visually, it's easier to see what y value you're dealing with. And so here at 1, the y value I'm hitting is the value at 1. Okay, remember yesterday on some of those, when I would go up, it would actually be the previous y value. That's where the I minus 1 comes into play. Okay, now if I want to find all the possible rectangles, if I want to sum all those up, I'm going to use a concept that I learned about earlier, and that's the limit. Okay, and so what this will do is this will take into account, like the upper and lower sum, it'll sum everything up. Okay, so I'm going to go ahead and take the limit at the very end, and you'll see that that works out real slick. So I've got the limit as n approaches infinity. Okay, I'm going to sum from 1 to n. And I'm going to take 1 over n times, what do I do with this I over n? Plug it into the cubed. Okay, so really that gives me I cubed over n cubed. I do, it's right here. It's cubed. Okay. So now if you remember, I want to only have I to the right of the sigma. I want to move everything else to the left. So I've got the limit as n approaches infinity. What am I going to move to the left of the sigma sign? The 1 over n to the 4th power. Why 4? Because I've got 3 and 1. That makes 4. What's going to be inside? I cubed. There we go. Good. Okay. So yesterday, do we have anywhere where we simplified I cubed and multiplied it out? think so. It could save us a lot of time if you can. Maybe we didn't have an I cubed.
Shoot.
I don't think we did, so we're going to have to go ahead and multiply that out.
Nuts.
I cubed, if you remember, was n squared times n plus 1 quantity squared all over 4. Okay? So I have an n squared. Let's go ahead and FOIL that out with our trick. Remember what our trick was? First term squared. All over 4. And then let's go ahead and distribute the n squared. So I end up getting n to the 4th plus, okay, so let's go ahead and put that over here. So n to the 4th plus 2n cubed plus n squared all over 4. Yeah, you can do that. If you want to go ahead and break that up. If you didn't catch what Ross was saying, could I just put all of them each over 4? And the answer is yes. And that would save us a step. So you would have over 4, over 4, over 4. Okay. So now we've got the limit as n approaches infinity. Let's go ahead and distribute that n to the 4th to each of these. 1 over 4, very good. Plus 1 over 2n, good. Plus 4n squared. Yeah, good job. So now what we're going to do is, if you remember from yesterday, this would be classified as the upper sum because the rectangles were above. Okay, what we're going to do is we're going to evaluate this and we're going to take the limit. And so first of all, we know the limit of 1/4 is just going to be 1/4, right? That was the limit of a constant. We know the limit of 1 over 2n. This follows those limit rules. Remember where the degree of the numerator is less than the degree of the denominator?
Yeah.
And if you remember, the degree of the numerator less than the degree of the denominator,
Equals 0. Oh, equals the.
that one
So it
actually,
doesn't
One
exist.
yeah, it doesn't exist. It actually goes to infinity, okay? So these are actually gone. We can actually get rid of those. Same thing with the third one. So your limit totally is 1/4.
Oh my.
And so that is the area under, okay? So you got 3 problems like that.
Holy cow.
The other one remains like longer than that.
Alrighty, so
No.
actually they aren't. Your 23 through 30 are just, I mean, those are just kind of looking at your rectangles.
How do you do it?
And then your 47 through 49 is this, like the very last problem we did. So.